Hello everyone, welcome back. Today we'll talk about methods. Methods are nothing but functions declared inside the class. Uh, in our last video, we introduced the concept of the class and we focused on the fact that a class is a way to structure a set of data. Mean, if we want to model a real object, last time we took the example of a person that have different characteristics such as name, surname, birthday, birthplace, and so on, we use such concept of a class to include a set of possible variables describing this object, such as the person. But the class is not only a way to gather some data, to gather some variables that model something. A class may contain as well functions, which in the programming terminology, we call them methods. So methods are nothing but functions. So let's go over the concept of a function. What is a function? A function is nothing but a set of instructions that have a specific goal, a specific aim, and we want to keep this set as a unique block, say as atomic. So either execute all of them or none of them. Just for the example, we have a function called a rectangle area, which takes in input two parameters, in this case, say side A and side B, so the two representative sides of the rectangle, and returns the surface, which basically it is nothing but the product of these two parameters. Why we use functions? First of all, we use functions because of modularity. Suppose that we have an application, a very long application with many features. Obviously, we cannot think of writing all this code in a single file. We used to separate, we used to split, we used to divide into modules or functions. Moreover, if we make use of a specific business logic, so a set of instructions, if we use them several times, suppose that in several occasions we need to calculate the area of the rectangle with different input area, there is no need to write the same code again and again. So we build a function that holds this business logic, and based on the input parameters that we give, it makes the appropriate calculations. Moreover, in order to maintain our code, it is much easier and safe to use functions, because if we have repeated the same set of instructions several times, and suppose that we find a bug, or we just want to extend, to improve that code in order to include other features. So that if we don't use functions, we have to remember all the places when we have used our code and try to change it or to fix it. Instead, if we use the function, the set of instructions is in a single place inside the function. So we have one single area or one single memory space where the code is stored. So in the same area where the function is located. So if we need to do some changes or some improvements, we have only one set. And all the other parts of our program makes use, so invokes the function that we are interested in. There are some built-in functions which we usually use, like for example the print. So this is a functions provided by Python, and some functions that we create ourselves. With the same approach, we implement methods. So in the language or in the terminology that we use for the object-oriented programming languages, we use the term method to express the concept of the function. And as well, in the class, we have some built-in functions. The function, for example, that we have seen last time when we introduced the concept of the class, the init method, which is used to initialize a specific object. This is a built-in because it is already included and defined in and has a specific goal in Python. But we can declare as well our functions, our methods inside the class, doing some specific tasks. How we declare functions, as we already know. In order to declare functions, we have to use the keyword def, the function name, and list the input arguments. Return a possible value if the function returns something, because we might have the so-called void functions, which they do not return anything, but they execute some instructions, they do some business logic, and they might not return. In this case, we want to return a specific value, which is nothing but the area, the rectangle, or the multiplication of the two sides. And in order to invoke the function, we use the function name along with the input arguments, and we store the return value, if there is any, in a variable. And we can make use of our variable according to our business logic. But if we want to declare a method inside a class, what does it change? It's more or less the same, with a small difference. If we want to declare a method inside a class, we start with the keyword def, the method name, and the particular aspect here, or what changes from the classical functions, is that we have to use a variable. Usually we use the keyword or the name self, but you can use any other name, to identify the instance of the object. As we have formerly seen, to refer to the attributes of the class, even though we might not need it. So in this example, we have already the two data that we need, so side A and side B. So we don't need any specific attribute or any further value, but still in the declaration, we have to include it. Then we have our business logic and a return value. So let's write this example. So let's write class rectangle. Let's define area, which takes an input, a variable used as a self-reference, so to refer to the instance of the object that we will create, side A and side B. Just to extend a little bit, side A per side B, suppose that our business logic is a little bit more complicated, return area. Now, I have made use of the term area several times, but intentionally. And I will introduce you why. So R equals rectangle. So R is an instance of the class rectangle. So if we want to invoke the method area, we have to refer, so to use the dot notation, area and let's say 2 values. Let's store it somewhere at some variables and print area. And we have the value 10, which is nothing but 2 per 5. We have used several times the term area. This is not an issue in programming because, as we can see as well by the color itself, area here is the method name. And in order to invoke it, obviously, we have to use the dot notation. And not like in the functions we used to define area 2.3 and say return red value as we used to use for the functions. Instead, we need to refer to the instance. So without the instance, that method cannot be invoked. Python is able to give the semantic of these variables. So is able to distinguish the fact that this is a method, this is a variable inside the method, and has nothing to do with this variable, which is the variable of our program. So even though the names are the same, these 2 variables are completely different. This is the method inside this is a variable inside the method, which is private for the method, and this is the variable for our application. I discourage the usage of the same name because it might be confusing, but it brings no problem while programming. So what is the utility of having the method or the functions inside the class? Because we can use it as well without. One utility can be while providing a class with a set of methods, like an utility. So we build the class and we know that that specific class contains a set of methods that are useful to us. And we can share this class with others. So we can say, okay, we did the program. This class contains quite a lot of methods that are suitable to you. So you don't have to implement the same method. These are available inside this class. Another utility is the fact that we are aware that classes have attributes, have some values included. And in general, when methods turns useful, methods usually make use of one or more attributes. They are not just similar to the functions, because with the functions we have to provide from the user side all the data, everything. Instead, for the class, we can make use of some of the attributes, and the moment that we have a need for further information, obviously, this further data can be provided as user input. For example, as a rectangle, we can define a constructor determining the rectangle. Def init, always use this variable referring to the instance, side A, side B, and self dot side A equals to side A, and self dot side B equals to side B. Pay attention that even though they have the same name, these two are different variables. These are the attributes of the class. These are the input variables. In order to not generate any confusion, we can use as well different names. What about the method area? We need two values. The two values that characterize the rectangle. So we already have as modeled as attribute of our class these two variables. In order to refer to these two variables, self, we need to use the reference self dot side A, self dot side B, in order to declare that we are using attributes of the class and not to input parameters, to input arguments of the class. So when we declare a rectangle, we have to provide, let's say, 3, 5, because the moment that we initiate a rectangle, we use its constructor. And the values, the input values, will be assigned to the two attributes, attribute side A and attribute side B. So these two values are already incorporated inside the class. So there is no need for further information. Even though we have an attribute for the method area, when we invoke it, we don't provide any value, because this argument is compulsory, is obligatory, and is used as a self-reference, so doesn't give us any additional value. So if we have two parameters, we have to declare the method with 3 parameters, where the first is always a self-reference. So we declare an instance of the rectangle. We declare the class rectangle along with the input parameters of the constructor, side A and side B, which we store in our arguments. So there is no need for further information, because I already have all the data that I need, which is nothing but the two sides, because at the end, they are just a product of these two numbers. And let's run, and it's 15. So a class turns to be not only a collection of some data representing specific objects, because as we observed in the last video, we can generate several instances, let's say rectangle 2 with completely 2 different values, but as well it incorporates some methods useful to our calculations, and that mainly make use of one or more attributes of the class itself. So we don't need to provide such information again and again all the time, but we provide, so we initiate the class with the known data, or with the data that represent basically the class, along with, so we provide the class, we provide the data along with some methods that turn to be useful to our program. And those methods make use generally, but not only, of the attributes. Obviously, such classes might have any additional values or additional data that we might need that might depend from context to context. This is all about methods. See you in the next video.